This is lesson 9.1, example 3, where we are in charge of telling whether or not the triangle is a right triangle. Basically what we need to do here is plug the values that we have into Pythagorean theorem to see if in fact a squared plus b squared does equal c squared. So let's begin. So for number 1, the longest side needs to be our c, because that's the way it will fit into Pythagorean theorem. So we'll have 5 squared plus 8 squared, really in any order. What I do is I like to put a wall right here because I don't know if they're equal or not. I'm trying to check that and verify that at the end. On this side of our wall here, I'll have 12 being squared all by itself. So in cleaning up the left side, we have 5 squared as 25, 8 squared is 64. Adding those together, we end up with 89. Over on the right side, 12 squared all by itself is 144. Those two values do not come out equal. So therefore, this is not a right triangle. Number 2, if you're unsure of which one is the largest side, especially with this unique value here, this simplified radical, go ahead and punch that into your calculator, and what you will see is that value is approximately 14.14. So therefore, that's got to be our c value as the longest side. So we will have 10 squared plus 10 squared on one side, and we will have 10 square root of 2 as an entire set being squared. You can also square root the 14.14, but keep in mind that number was estimated and rounded, so at the end it may make our values slightly off and our decision at the end a little bit more difficult. Over on the left side, 10 squared is 100, so we will add that to another 100, and that combines to be 200. Over on this side, it's a little unique situation. Watch carefully. You'll have to square both items inside the parentheses. So we will have to have 10 squared being multiplied by the square root of 2 squared. And 10 squared is 100. The square root of 2 squared, remember, we'll do nothing more than just take away the square root and leave us with the value inside. And 2 times 100 is 200. So we do in fact have a right triangle this time around because we have 200 equal to 200, or a squared plus b squared being equal to c squared. Finally, number 3. Pay very close attention that the numbers are out of order and that the 9 needs to be our c when we plug it in. So we have 4 squared and 6 squared as the two smaller sides, 9 squared as our largest side, the hypotenuse. So we'll have 4 squared plus 6 squared, with 4 squared being 16 and 6 squared being 36, for a grand total of 52 on the left side. 9 squared all by itself is 81. Those do not come out equal like we wanted them to in Pythagorean theorem, so again, this is not a right triangle.